Good afternoon, my YouTube viewers. Crystal here. I'm here this evening because what I wanted to do is I wanted to show you the code that I put forward on the Kaggle Titanic machine learning competition. And basically what I used was Keras TensorFlow, and I just loaded it up within the last half hour, and I got a 78.468 percentile, which is the highest percentage I've achieved working on the Titanic competition. So I wanted to show it to you. As you can see right here, the code works because I'm showing you right here that it works. And you can see my previous score. My previous score was 3 days ago, and it was the decision tree. And I scored 75.119. So my score today was with the Keras, and it was 78.468 percentile. The thing to keep in mind is I was reading somewhere that most people are not going to score above the 80s in this competition unless they actually go into the internet and research the survivors and put in their code the information that on the survivors that they need to get all of those survivors correct. So I did not overfit the model. I just fit the model using the algorithm presented to me. And I did actually, it was all my own work except for the TensorFlow part of it itself, because obviously I'm still learning and I'm new. So that's not something that I could make up. So I had to get that from another location. But what I'll do is I'll go into my notebooks, and I'll go into my work, and I'll go into Keras. And what I'll do is I will share it so anybody who wants to look at it can see it. And basically what I've done is I've got the website of where I just got the code for the Keras itself. Everything else is my work. I mean, cleaning the data, that's all my work. The only code that I borrowed was at the very end when we had this TensorFlow Keras model. So I'm just going to go over the code with you, and since I have shared my program and made it public, you can always look at it and go find it and look at it. So I've imported my libraries. I know that I imported more libraries than what I needed, but I have a tendency to do that. And then I imported the machine learning libraries, which was Keras. And Keras has a lot of libraries because you have your input, and then you have a lot of hidden layers, and you have your output. I mean, at the moment, I'm actually taking a course on Keras, or machine learning, or neural networks. But what I have a tendency to do is I'll have a tendency to put the course away and then start working on a problem, because I feel like I need to be working on problems. So I set up these utilities, and that's something that I got from that website, and then I just put it in there to make sure that the system didn't crash when I tried to run it. So we imported our files, our test file, train file, and our submission file. So we read our train file and our test file. So you can see the train file, and you can see the test file. And we've got the test info, which I had train info, and I've got a test description, which I had train description. And now what I've done is I put code in there to see if there are any null characters anywhere in the data frame. And yes, we found out that there were null characters in the train file and test file. And so what I did was I submitted code. So in the cabin, fair, and embarked, any null characters were replaced with the mode, and the mode would be like the center in the column. And we replaced the age with the median age. Then I did another test to see if there were any missing values, and no, there are no missing values. So you can see the train file and you can see the test file. So the next thing I did was I took the title out of the name. I didn't actually use the title in this instance, but because I went to the trouble to extract the title out of the name, I thought, well, I'll keep the code in there because I may need the code for something else sometime. And then I did a group by on the title. But one of the things that happened, and I'm not sure exactly why that is, there was a title called Donna, and that title was not included in the titles. And I think it was because it didn't have a comma and it didn't have a full stop. And that's why it wasn't included in there. And so whenever I found out there was a null character, because at the end of all your work, you have to go through and see if there was a null character. And then that's how I found out there was a null character. I went and found out that it was this Donna that was the null character. So I put the Donna in the little dictionary that I made, and then I mapped the dictionary into the title column that was made. Even though I didn't use it, I decided that I was going to go ahead and keep that code in there just in case I needed it for anything. So the next thing we did was we checked the class. There were 3 classes, and we also had a little graph to see the number of people that bought first, second, and third class tickets. And then another thing that we did was we set up bins for first, second, and third class. And the thing that you need to keep in mind is bins has to be one more than the names. And if you don't do that, it won't work. And then if you put the first character has to be less. The first number has to be less, because if it isn't less, then it won't pick up all of the values, and then you'll end up having null values in there. And that is something that I found out when I was doing this work. And then I just found out through experimentation that if a value is 1, to go ahead and put a -1 in there. So sorry, if a value is 0, go ahead and put a -1 in there to make sure that you capture everything even close to 0. So at the end of this work, I did a test and I found out that there's not any null characters, because if there's any null characters, you have to go through and troubleshoot and find out what caused the null characters. Then we did the same thing on our sex. We had a male and a female, and we mapped the male and the females to the sex column, and we had a chart of male and female. So you can see that there were more males than women on the Titanic, but more females survived than men. And more children survived than men as well. So what we did was we had to set up another dictionary. So we had to assign male to 0 and female to 1, and we mapped that. And so that was mapped into the sex column. So you can see that we had 109 male survivors and 233 female survivors, which totals 342, because there were 342 survivors in the train set. And again, we tested to see if there were any null characters, and no, there are not any null characters. The next thing that we did was we tested the age. And so what I did, and I did a violin plot of the age, so you can see that most of the ages were like in their late 20s. And so we made a graph of the ages so you can see the graphs. But we also created some bins of child, young adult, middle-aged, and pensioner. So we, rather than having all of those ages, we just allocated them into that segment. And then you had child, young adult, middle-aged, and pensioner was assigned a number, and that was mapped into the column. And so at the end of that, we did a test to see if we had any null characters, and no, we did not have any null characters. So again, what we did was we had to check the age range, and every age range was assigned a number, and you can see that that totals 342 because we did not have any null characters. The next thing we did was we tested the family, and that falls under the sib spouse column. And so every number was assigned the number of people survived. And what you can see is people who were single had a greater chance of survival. Really, people who were single and couples had a greater chance of survival than the families. And we had a violin chart, and here you can see that the people who were single and the couples had a greater chance of survival. So what we had to do is we had to put these in bins and assigned everything a number, and we mapped that into the column, and you can see here is the family range again, and it totals 342. The next thing we did was we checked PARCH, and I think that stands for parent-child. One time I saw the work of somebody, and he took sib spouse and combined that with parent-child and added a 1. And he said, that was the size of the family. And I tried to do that, and I didn't really do it correctly. And I just thought, well, I'm just going to keep sib spouse and PARCH separate. But here's your PARCH. I believe that means parent-child. And so we've got, if it's 0, if there's no parent or child, then they had a greater chance of survival. And if there was only one person with them, that had a greater chance of survival. And maybe 2 people with them, but any more than 2 people, they didn't have a very good chance of survival. And I think the reason for that is because if you were traveling with a family, then you wanted to be with your family, and you wanted to be making sure that your family was okay. But if you're on your own, you only have yourself to think about, so you can get off that boat. And I think that is why people who were traveling with families had a lower chance of survival than the people who were on their own or were just a couple. And so we have a violin chart that again shows that people who were single had a higher chance of survival. And again, we put this in bins and gave a name to each bin, and we put that into the column. And we grouped this, and you can see that totals 342, being the number of survivors in the train file. The next thing we did was we looked at the fares. And so we've got a violin chart of the fares, and you can see that the lower fares, there were more lower fares than there were higher fares. But what I did was I grouped them into hundreds, and I put that into the fare range column. And you can see that the 0 to 99 pounds, they had a higher rate of survival than the higher ticket prices. And I believe it was probably because if it was 0 to 99 pounds, then they only had themselves to think about. So maybe they only paid for one ticket. But if it was a family traveling together, they may have paid for a family ticket, which would have been more expensive. So again, we tested for any null characters, and no, there were not any null values. The next thing we did was we did an embark, and there were 3 locations that the Titanic embarked from, C, Q, and S. So people in Southampton, they had a higher incident survival than the people in the Q and the C. So what we had to do is we had to map the C, Q, and S to give it a number, but we also had to bin them, categorize them. And at the end of that, we tested to see if there were any null characters, and no, there were not any null characters. So that's marks the end of our columns. So the next thing we did was we put in some more code to see if there were any null characters after we did all of that work on the file. And no, there were no null characters in the train file and no null characters in the test file. And just for safe measures, we tested to see if there were any null characters anywhere in the train file or the test file. And no, there were no null characters in the train file or the test file. So you can see the train file and the test file. And so you can see the train type. So you can see all of the columns that I made are now categories. These are all the columns that I made. So ticket is an object, but we're not going to be using that. And name is an object, but we're not going to be using that. And everything else was numeric. We checked the D types of tests, and you can see that's the same. So what we did was we created a heat map so you can see how the different variables fit in with the survivors. So the columns that we dropped were name, ticket, cabin, and title. We dropped that on the train file and the test file. And we set up our Y value, which is train survived, and we set up our features of class range, sex range, embarked range, age range, family range, parts range, and fare range. We set up our X as PD get dummies train features and X test as PD get dummies test features. And I wanted to see what X looks like, so you can see what X looks like. You can see all the different columns. And we wanted to see what X test looks like, and you can see what X test looks like in all the different columns. So what we did was we split our training file up into X train, X validation, Y train, Y validation. And so what we wanted to do was we wanted to check Y train value counts, and there were 61.68% didn't survive and 38.32% did survive. And we wanted to check Y validation, and that had the same figure or a close figure. And the next thing we checked was X train shape and Y train shape. So X train shape was 668 and 31 columns, and Y train shape was an array of 668. The next thing we wanted to do was we wanted to check X validation shape and Y validation shape. So X validation had 223 rows and 31 columns, and Y validation shape just had 223 numbers in an array. So this is where we have created the simple arrays, simple Keras network, and that is I had to actually use that algorithm because I'm new, and I'm still learning. That's not something that I could just type up myself, but I'm going to be taking a bunch of Keras courses because it looks to me like Keras is more accurate than some of the other methodologies. So we did a grid search. That's some more code that I had to borrow from that person because I'm just learning. I can't do it all. And then what we did was we created a classifier with the best parameters. And then we made our prediction. And so basically our prediction was X test, which we had set up here. I'll show you. Right here was X test. And then we down towards the end of the program, we actually used X test. So after we predicted our model, we created a file and we used passenger ID from the test file and survived from prediction. And we made a file called submission. And this is that file called submission, because I always want to see the file before I submit it, because if I can see the file before I submit it, then I have a good idea whether it's going to be accepted or not. And I don't want to, my file not to be accepted. And as you know, my file was accepted. I got a 78%, which was the best score I've had on Titanic since I've been working on it. And that's why I wanted to make a video to show it to my viewers. So if you like my video, please like, subscribe, and share. If you like the work I'm doing, if you want to leave a donation, I've got my email address to my PayPal account down below, because I don't have enough subscribers. So I'm not able to make any money on my videos. So any donations will be very greatly appreciated to help me get a more powerful netbook at some point in time, because I'm going to have to get a netbook that's got like I believe 16 meg RAM and 1 terabyte of memory. So any assistance that I can get would be just wonderful. And let me know what you think about my videos. Thank you so much for watching this video to the very end, and I look forward to making the next one for you. Goodbye.